Hola, estudiantes. Oh, wait, that's for my Spanish class. Hey, students. Today we are going to learn about physical and chemical properties and physical and chemical changes. Now, in order to understand these types of changes and properties, you have to understand the particulate theory of matter. You can go back and review the video in Unit 1.4. But in order to fully understand the chemical nature of chemical changes and physical changes and chemical properties and physical properties, you need to understand that. So let's start here about the difference between chemical and physical. Okay, so physical changes or physical properties have to do with the appearance of a substance. Okay, so a physical property would be something like color. Okay, color is a physical property, and if something changes color, that's a change in its physical. That's a physical change. Okay, now another thing is size. If you have something that, if you're measuring something's size, that's a physical property. If you change its size, typically that's a physical change. So anything that has to do with appearance is typically physical. Now, chemical changes have to do with with what the piece of matter, what the substance is made out of, it has to do with its composition. So the easiest thing is to say this is how things react. So if you're describing how something reacts, that's its chemical properties. So if something is let's say something rusts, metal rusts, okay, that's a reaction that you're doing. If something burns, that's a chemical property. The burning is a chemical change. Okay, so chemical has to do with how things are made up. Physical has to do with appearance, and that's an important distinction. Okay, now when we talk about the particulate theory and how physical and chemical relates to the particles, you have to understand that particles are held together by specific types of forces. There are two types of forces. There's intermolecular forces and intramolecular forces. Okay, intermolecular forces we abbreviate as IMF. And what they do is they exist between particles or molecules of stuff, and they are attracted to each other. So this guy is attracted to this guy. You're like, yay, see, they're all in love, and they're like, yay. Okay, so there's an attraction in intermolecular forces, and we abbreviate that IMF. Intramolecular forces are what we call bonds, and I've already learned my lesson. I am never going to call it an intramolecular force. And so what a bond is if you have atoms in a molecule, they are held together by a very, very strong force that is called a bond. Okay, so what does this have to do with chemical and physical properties or chemical and physical changes? Well, in order to really understand this, let's try to draw the picture a little bit better. Okay, so this is going to be a water molecule, and most of you know that water is H2O. Now, H2O is connected, the H is connected to the O because the electrons overlap, and we'll get into that later. But the idea is this is a very strong connection between the two. So that's a bond. Okay, and here's another bond. And so what happens is this whole unit here is now considered to be one big thing, and we call this a molecule. Okay, and that molecule is held together with these bonds. Okay, so it makes this whole big thing one part. Okay, and so if we're going to talk about those changes, here we go. I'm going to draw the bonds in water here. Okay, And then what may happen is when we react water with stuff, I know that sounds weird, but what we can do is we can run electricity through water. Okay, and when we run electricity through water, we rearrange the atoms that make up the molecules. So now instead of hydrogen being bonded to oxygen, hydrogen is bonded to itself, and we show that by the overlapping spheres. And so water at normal temperatures is a liquid, okay? But now we've changed the composition, and these two things, this is a gas and this is a gas. Hydrogen, we find hydrogen as a gas. We find oxygen as a gas, okay? So this is one way we represent changes in the bonds, okay? Now, you can see that this is a chemical change because what we're doing is we are changing that force that's holding together the molecule. We're changing those, okay? Now, one of the things that may happen also, we may represent, let's say, this triangle, and now the triangle goes and becomes a rectangle. Now that's because particles, if the particle changes, it takes on a different characteristic. So it's very possible that a chemical change can cause a physical change as well. A chemical change can cause, that's a lot of C's, can cause a physical change because what you have is a different compound altogether. So this is a chemical change, but you're going from a liquid to two gases, and so you're changing its appearance, but more importantly, you're changing its, let me make sure I spell physical right. You're changing the way it, yes, you're changing its appearance, but more importantly, you're changing its composition. Okay, so, okay. Now, intermolecular forces are between whole particles. So here, what I'm going to do is I'm going to represent that with just a dotted line. So again, you have a particle, or in the case of water, you may have two particles, okay, and those molecules are attracted to each other. Okay, now that's an intermolecular force, and we use dashed lines to represent those. And this is not necessarily as strong as a bond. Okay, it's very rare that you see an intermolecular force as strong as a bond. Now, what happens when something boils, which means you're going from a liquid to a gas, you're going through a phase change, okay? The intermolecular forces are attracting those molecules and making them a liquid, okay? They're not making them a solid, so they're not super strong, but the intermolecular forces are making sure that that stays as a liquid, making the molecules together. Now, when you heat it up, as we saw in the last section, when you heat it up, the molecules are able to move faster and they have more energy. And what happens is the molecules are able to spread out a little more. And now the molecules are overcoming the intermolecular forces, the force of attraction that is holding them together. And so now they are moving independently from each other. Have we changed what the two things are? No, we haven't changed that this is a mercury atom and this is a mercury atom. So it's a physical change, but it just merely looks different because we're overcoming or changing kind of the intermolecular forces. So that's the fundamental difference between a chemical and a physical change. Chemical change is a change in the bonding. A physical change is a change in the intermolecular forces. Okay, so everything is all based on particles. Okay, and so if the particles change, if you're changing the structure of the particles, then you have a chemical change. So the question that I always like to ask is this the same thing from when you start, when you end? Okay, so if you rip a piece of paper in half, Is the paper still paper? Yes. Well, that's a physical change because what you're doing is you're overcoming the forces, the intermolecular forces that are holding that paper together. You are stronger than the forces that are holding the paper together, so that allows you to do a physical change on the piece of paper. Now, if you burn that piece of paper, now is that pile of ash at the end the same as the paper at the beginning? No, it's not. That's a different thing. It's a whole different composition. Okay, so that's a chemical change because you've broken bonds and you've made a pile of carbon, and the hydrogen and oxygen have left that's in the paper, and it's either left as gas or more likely as water. Excuse me. So those are the things that deal with chemical and physical changes. Okay, so as part of this assignment, and I'll post this, what I want you to do, don't worry about this or this, okay? You can do this as part of the supplemental, okay? But I want you to do these problems in your book, and it's right below this assignment in Schoology, okay? I want you to make sure that you defend your answers using the appropriate definitions. Okay, I'm going to check this, and so this is going to be kind of like your wrap up for the assignment. Okay, if you have any questions, feel free to ask. Okay, there it is.